like just go all over the booklet and just try different things. That's my plan right now. So let's go first and foremost to page 37. Some of you probably already have this. This was the homework question. Like your homework was just to watch this and fill this into your notes. So if you haven't done that, you can still do that. I go through this whole thing, but this I would say is also a classic. I would put that on top of classic question. And I'm not just saying test, I'm also saying exam. This type of question. It's kind of where you can clearly tell within the question that something happens first, and then being on either leg of your outcome will affect the second event. Okay, so this is a very good, I would say, very important concept to have. What you need to watch out for is that they only give you part of it. So this one, for example, if the sign is up, then if it's 0.83, then there's a 0.17 chance that the sign will not be up. And if the sign is up, there's a percent chance of somebody falling or not falling, right? Falling, not falling. So the red part, I always calculate it's the complement, right? They should always add up to 1 in each case. Let me take you to page 40, because this one I have a video already. So if you don't know what I'm talking about, I would strongly encourage you to try that. Go ahead. Let's go to 40 here. Some of you tried that on the whiteboard. Let's do this one. How many of you have 40 done already? In hands up. Gabby, Eliza, a couple of you. Way to go. Way to go. So you can just sit back and relax. You can check your social media. An ultimate team, ultimate frisbee that is, right? Team has a 60% chance of winning on calm days and a 70% chance of winning on windy days. That would not be what I would do. For me, it would be the other way around. But anyways, tomorrow they have a game. The weather station predicts 40% chance of high winds. What is the probability that they will win tomorrow's game? And I will add to this question, by the way. You have to ask yourself, when it's like this, the province will ask you, sometimes they'll ask something like this. Create a visual representation of this scenario with all probabilities. Okay, so there will be specifics like, hey, we want you to create this diagram. We want you to have all the values, all the calculations of probabilities in there, okay, to get the 2 marks. Usually it's 2 marks. So here we go. What comes first, windy or winning? What do you think would come first? Windy, right? Whether or not it is windy is what you would come down with first. So we go windy, not windy. Okay, so windy, not windy. Put a bar on top like that. So it says that there's a 40% chance of high winds. Okay, so there's a 0.4% chance or 40% chance. That means that there's a 0.6 chance or 60% chance of it not being windy. And under each circumstance, oh, this is going to be tricky because it's W, wind. I will call it something else. I'll call it game, not game. Winning the game, not winning the game. Okay, that's usually how it goes. So on windy days, There's a 60% chance of winning. No, sorry. I have to be careful here with the reading. I did this on purpose. 70% chance of winning on windy days. So this is the one I'm gonna attribute to this branch right here. If it's windy, there's a 70% chance of winning. Therefore, there's gonna be a 0.3, a 30% chance of not winning the game. On calm days, right? This would be not windy. There's a 60% chance of winning, and therefore a 40% chance of not winning the game. So that would be the start of your tree diagram. Okay, so let's figure this out. This is probability of winning and and winning the game. This is probability of it being windy and not winning the game. This is a probability of not being windy yet still winning the game. And there's a probability of it not being windy and not winning the game. And I will just use my calculator for this, or you can just, right? So it's 0.4 times 0.7. So I'll just put down 0.28. Okay, 0.28. This is 0.4 times 3 is 12. 6 times 6 is 36. 6 times 4 is 24. 0.24, that is, okay? Does this add up to 1? Feel like?
Yeah, it does.
Phew, it does. Right? You always want to check, like, oh my, is this right? Yeah, it does add up to 1. Okay, so we've got all the probabilities, so this would be a 2 out of 2. So the question is asking, what's the probability? This is what it's saying. What is the probability that they will win tomorrow? So probability of W, and that would be 0.28, because it has a, sorry, sorry guys, it's the, I have to be careful. Winning for us is G. So probability of G, and you're probably thinking, G, get it right already. Okay, 0.28 plus, there's another G right here, 0.36. Now we're talking. 0.64. Or 64% chance of winning. Okay, that's how you do this type of question. So overall, randomly, there's a 64% chance of winning based on this question here. I'm gonna ask you to write this one down. Okay? This is gonna be a B to this question. What is the probability? What is the probability of it being windy given that the team won? What in the world are they asking me there? And I would focus in on this part right here. Being windy given that the team won. And if you watch the video, yesterday's video, you will see me doing this several times. this type of scenario. When you have the given that something already happened, guys, translate this. What are they really asking me for? They're asking me for the probability of it being windy given that the team won. Okay, so what would go here? What letter would go here? G. That's what this question is asking. Okay. And this is how you do it. This is how you develop the formula to solve this. You ready? It's W and G. So you're like, well, this is obviously a dependent situation. So probability of windy and winning the game, because they're dependent, guess what comes second here at the end? At the end, you're going to put this down because that assumes or gives us the hint that something happened before. Probably windy given that they won the game. So this is what you put up front, the probability of winning the game. Okay. That's what you put up front. The G is what happens first. And now if you read it again, it's like, hey, probability of windy and winning the game is probability of winning the game times probability of it being windy given that the game has been won. Okay? So now we just plug in and go. Probability of windy and winning the game. Where is that? Windy and winning the game is right here, 0.28. Probability of winning the game, we already calculated here, 0.64. We added up these two numbers. So that's 0.64. And this is just x. We're just going to turn that into x. It's just a lot quicker. So here, all we have to do is divide both sides by 0.64. Boom, like that. X is going to be 43.75%. Sorry, that was a little crowded there. Okay. All right, so what else do I want to do here? Let me just look at some other questions here. Question 5 looks good. 6. Let's go to 43. Question 11. Question 11. 3 cards are drawn from a standard deck of cards without replacement. That tells us dependent events, right? Calculate the following. The probability that all 3 cards are aces. What I don't like about this question is that it doesn't tell you that they're being picked in a row, okay? But the without replacement kind of indicates that, right? Drawn one after the other. Okay, drawn one after the other. So A. Let's assume this is a quiz or a test right now. How would you do this? There's 3 cards being drawn, correct? You're not replacing them. So you should start with 52, then 51, then 50. That should be that would be a 1 mark right there. Me looking at the denominator, is it dropping by 1? Okay, next. All 3 cards are aces. How many aces do you have at the beginning? 4. Then you have 3. Then you have 2. That's it. So that would be 6 times 4, that's 24. Over. I don't have the key in front of me, so I'll just... that's 132, 600. I'm just going to leave it like that because that's basically what I need you to be able to do. B. Probably that all 3 cards are black. How would you do that one? Well, I'm drawing 3 cards one after the other, so hey, the total doesn't change. Like the way I'm dealing with the denominator stays the same. They're all black cards, so 26, 25, 24. Let's be creative here. This could be written as 26, pick 3, 52, pick 3, correct? Would you agree with this statement? Just translate it. You don't have to, but it can be. Okay. That's 15,600. That's 132,600. Oh yeah, I already knew that. You're asleep. Okay. Okay. That's a little reduced, not completely simplified. What about C? All 3 are the same suit. How would you do that? Is this cases perhaps? Because they could all be clubs, all be spades, all diamonds. So you can branch off if you want. The stars kind of give it away, right? What I will do is this, watch. I have 3 cards that I'm pulling. So this is 52, 51, 50. If I talk about one suit, it'd be 13, 12, 11. And watch what I'm going to do to this answer. I'm just going to say, hey, this happens 4 times. 4 suits. You could do this 4 times and then just add up your answers or do what I just did, right? Whatever works for you is fine. So we have 132,600 at the bottom. We know that already. Sorry, I have to put the 4 in front. Don't forget about it. 13 times 12 times 11, that's 1716. So here you have to be careful. What do you want to do? One choice is probably going 1716 divided by 132,600. And then I'll just multiply that by 4. Okay, so maybe I'll show the work here. That's 4 times 0.0129 dot dot dot. I'm just going to multiply that by 4. That's 0.0518 or 5.18%. Do I have that review at the back? Yes, I do. Yeah. Okay. So what we're going to do now is I'm going to send you to page 51. Can I write that? I think I want to write this down at the very front of your booklet. Reviews on page 51. Review on page 51. And so I'm going to give you the rest of, I mean, there's not much left, but let's make it a point, right? I'm going to ask you to work on this for tomorrow. And I want you to, how many pages are there? It's quite a bit. It's quite a bit, I know that. How about we go 51 to, I give you lots of space, that's why it also is longer than what it actually is. How about we do 51 to 53 for tomorrow? That's going to be day 1. And then we're going to go page 52 to the end on day 2. I think it goes all the way to 58. Day 2 and on, right? Because basically this will be to review for so I need you to do day 1 so that when we come back I can do the day 2 part as much as possible, that is, okay? And so practice, get exposed to the different types of questions, and we'll go from there. I think for tomorrow, what I would ask you to review is these tree diagrams on page 37. Like, make sure you know how to do that one. I will have a short AC on that, and then we'll just worry about reviewing for the test after that. Thank you, guys.